Adapting to the 2026 mindset requires an aggressive psychological shift. It's about moving from idea to execution in hours rather than weeks, treating development as a conversational, iterative process where you build, test, and ship immediately. This speed is possible because of what AI actually is, a system designed to perform tasks that typically require human cognition. It functions by analyzing massive data sets, finding the hidden patterns within them, and using those patterns to generate predictions. However, there is a clear limit to this power. AI currently functions as a turbocharger for existing human knowledge. It is not yet a primary source of truly original discoveries. Since the technology acts as an amplifier rather than a creator, the results depend entirely on the skill of the person behind the keyboard. Success belongs to the operator who actively directs the tool, not the observer waiting for it to act. For decades, artificial intelligence was a theoretical goal. That changed in 2012, when the AlexNet model proved that AI could categorize images with enough accuracy to be commercially viable. By 2016, the scope of these models expanded to strategic decision-making. That year, AlphaGo defeated human champion Lee Sedol, demonstrating that machines could master games of intuition and high-level logic. The acceleration became exponential after the 2022 launch of ChatGPT. We have now entered a cycle of continuous LLM improvements that are projected to increase in complexity through 2025. This growth is powered by a three-tiered AI stack. At the base is the infrastructure, specialized GPUs and data centers requiring massive electricity. In the middle sits the model, storing weights after intensive training. Finally, the application is the user interface you interact with. Because building and powering this infrastructure requires billions of dollars in capital, the barrier to entry is extremely high. This economic reality means a small group of well-funded companies will likely control the foundational technology for the entire market. To understand how those models are built, we have to look at the different frameworks of machine learning, the methods computers use to learn patterns from data without being given explicit rules. In supervised learning, models learn from labeled examples. In unsupervised learning, they scan raw data for hidden groupings. Self-supervised models predict missing words. Reinforcement learning uses rewards and penalties, improving through trial and error. These methods are what make large language models possible. An LLM predicts the next piece of language based on the massive amounts of text it has processed during its training phase. It processes this text through tokenization, breaking words, symbols, and even fragments of words into individual tokens. These tokens are the fundamental units the model uses to understand what you're asking and to generate a response. As these models become more capable, a geopolitical divide has emerged between the development strategies of the United States and China. The U.S. approach is defined by closed LLMs, supported by massive infrastructure and vast databases of text-based information. China has pivoted towards an open-source focus, emphasizing hardware, robotics, and training models on multimodal data, integrating video and audio alongside text. Despite these different strategies, all current models share the same strengths. They excel at pattern recognition, assisting with code, and automating repetitive digital tasks, where data is abundant and results are easy to verify. But they still struggle with the physical world and social nuance. They cannot apply true judgment or invent original concepts, and they will often state incorrect information with total confidence. Because the machine lacks its own internal filter for truth or originality, human domain expertise is the only way to ensure the outputs are actually useful. Succeeding in this landscape requires a specific human skill set, critical thinking to spot hallucinations, and deep domain knowledge to know when a model's output is actually correct. The core logic of human-AI interaction is this equation: output equals your prompt quality multiplied by the model quality. To master that first variable, follow a specific formula. Define the task, provide context, set constraints, choose a format, and provide an example. This structured communication is what enables vibe coding. It allows an operator to build functional software and prototypes through natural language conversations, using the AI to handle the actual syntax and architecture. By 2027, this interaction will expand as AI integrates images, audio, and video more deeply, eventually moving into the physical world through humanoid robotics. As the models become multimodal, the software itself is shifting from passive chatbots to autonomous AI agents. An AI agent is a system designed to plan and execute multi-step work independently. It can use external tools, verify its own progress, and repeat its steps until a complex task is finished. This shifts the focus of work. Agents automate repetitive screen-based tasks, from research and scheduling to complex coding workflows, acting as independent workers within a larger system. Ultimately, the value of the human operator shifts from knowing facts to using those facts creatively. By letting AI agents manage the execution of repetitive tasks, we can focus our judgment on solving problems and building new projects.